All right, I had to make a video for this lesson because the one that is on D2L goes over the same material but doesn't use these examples, and so I just wanted to make sure you understood how to do these examples first. So I had to do a specific video just for this. So after you do these two examples with me, then you'll go do your practice that's in your manual on lesson 2. Okay, so yesterday, just to reiterate what we looked at, we talked about how you can graph a sine or a cosine wave using your calculators to get the values of different angles, and then we would plot them on a graph, and they looked like this. So here were the two graphs that we looked at. Just ignore the stuff at the top. Okay, so just like we had like a parent log and a parent exponential function, and just like you have like the parent quadratic function like y equals x squared, there's parent sine and cosine functions. So we only had time yesterday to go over the positive sine and positive cos. I didn't mention negatives. But as you imagine, like with other functions, just like quadratics and just like logs, if you have a negative log function, it reflects the function. So it's like a mirror image along x. And so that's what happens with sine and cosine. So these are the ones that we graphed yesterday. So a positive sine function starts at 0, 0. And then there's a crest 90 degrees later. So this would be 90. And then 90 degrees later, you're back at the midline. 90 degrees later, you're at the trough. And then 90 degrees later, you're at 360. So here, this is a positive sine function. So say you put sine of 0 in your calculator, you would get 0. If you put the sine of 90 in your calculator, you get 1. Sine of 180 is 0. Sine of 270 is negative 1. Sine of 360 is 0. So this is what we did yesterday. The extra sheets are at the back of the room, or they're in your manual too. So you could go complete that graph just so you have it for reference. So the positive sine wave starts at 0 and goes up to a crest, okay? And the negative sine wave would look like this. This is a negative sine wave. It starts at 0, 0, but instead of going up to a crest, it goes down to a trough, down to a minimum. So it's just a reflection of the positive sine wave. Okay, like if you put a mirror here, the mirror image of the positive sine wave, there, this is the positive one. Okay, this is the negative one. They're mirror images of each other. So this is y equals negative sine x. So if you have a negative in front of the sine, it's the sine wave. It's just that it goes down instead of up to start. Now, our cos wave that we graphed yesterday looked like this. Okay, it started at, there's my kitty cat. It started at a crest, and it goes down to a minimum. And then it goes back up to the crest. This is one full cycle. Okay, so this happens at 0. This would happen at 90. This would happen at 180. This would happen at 270. And this is 360. So the cos wave looks a lot like the sine wave. It's just shifted over. Okay, so this is what our sine wave looked like. Like that. That was our sine wave. These are the same waves, just shifted a little bit. So cos and sine are very closely related to one another. So you're going to be given a wave. You're going to be asked to make a sine and a cosine equation from the graph. Okay, so while sine starts at midline and goes up, cos starts at the max, goes down to the min, and back up. Okay, so there's your sine and cosine waves. Now the negative cos wave would do the opposite of this dark wave. So instead of starting at a crest and going to a minimum, it would start at a minimum and go to a crest. So it would look like this. Okay, so this is the negative cos wave. All right, so this would be helpful to know because if you have to match graphs, Knowing what a negative version of the wave looks like would help you kind of figure out which one to match with what. Okay, so this is actually covered in one of the videos that I posted for you guys today on Teams. It's the first video. So if you weren't here yesterday, I would go look at that video. And at the end of it, near the end of the video, it goes over negative sine and negative cos. All right, so let's look at what you guys are doing today. So the supply teacher would have given everybody one of these sheets. The first page that you guys have, you don't need to do that. You can just rip it off if you want. I just accidentally photocopied an extra sheet. It's page 4 that you want to start at, which is this one. All right, so here's a sine wave, okay? Or you could say it's a cosine wave. You're going to be given these functions, and then you're going to be asked to make equations for them. Noodle, get out of here. This is Noodle, my cat. All right, she's getting out of the way. All right, so the first thing that you want to look for when you do you try to make your equation is you want to look at where the midline is. Okay, so your midline is the middle of the graph on the y-axis. Sometimes it's easy to tell, like if this is the top of the graph, which is in this case at 6, and this is the bottom of the graph, which in this case is at 2, then halfway is 4. Sometimes it's easy to figure out. If it's not easy to tell, you could just add the two values, the max and the min, and then divide by 2. So in this case, 6 plus 2 is 8, and then divide by 2, that's 4. Our midline is at 4. So your midline is written like an equation, y equals 4, just like when you did the axis of symmetry for quadratics. So when you did quadratics, your axis of symmetry was like x equals 5. It was an x value because the line went down through the x-axis. This line goes through the y-axis, so you say y equals 4. And that's the answer to the equation of the midline over here, y equals 4. Your max value is the maximum y value, which in this case is 6. Your min value is the minimum y value, which is 2. That means our range falls between 2 and 6, so it has to be bigger than 2, bigger than or equal to 2, smaller than or equal to 6. Now your amplitude, we looked at that yesterday. Your amplitude is just the distance from your midline to a crest, okay, which should also be the same distance as your midline to a trough, because if your midline is in the middle, it should be equidistant from the crest and trough. So your amplitude in this case is 2 units. Your period is how long it takes for a full cycle to happen. So if you look over at your graph, okay, you have to pick a reference point to start at. Like maybe we start here, okay? This is a crest, and it's going down, okay? So the next point where I have a crest, okay, and then it's going down is right here. So a period is how long it takes for this cycle to happen, all right? Now our x-axis is in degrees, so the duration of our cycle would be measured in degrees as opposed to time. Like x-axis could be time in the future for us. So going from 0 to 120 means that the period is 120. Sometimes it's not easy to tell the distance between the start and end point. So you could just go and subtract start, which is 120 minus 0, which is 120. So your period is 120 degrees. Your frequency is how many cycles happen in 360, okay? So if you look here, 360 is right here, okay? So if we want to know how many cycles happen in 360, well, this graph is easy to tell. It's 1 cycle, 2 cycles, 3 cycles. So 3 full cycles happen in 360, but sometimes it's not easy to tell. You might need to use the formula, okay? So remember, K is the letter for frequency, and you find frequency, we talked about this yesterday, by taking 360 degrees and then dividing it by the period. Okay, so our period was 120. Now this is always 360, it doesn't change. Your period might change. Like for this, our period was 120, but you could have a graph whose period is 90, okay? So this always stays 360, but this is gonna be different for every graph. In this case, it's 120. So 360 divided by 120 means 3. That means that 3 cycles occur in 360 degrees. Okay? 3 cycles. 1, 2, 3 cycles happen in 360. The last term, jump, we didn't go over yesterday, but all jump is it's how many units on the x-axis does it take to get to a major point on our graph. So the major points would be like crests, midline, and trough. Okay? Or instead of crests, you could say maxes, and troughs, you could say mins. So like those major points happen here. Okay, so those points all represent either midline values or max values or min values. And so if you're calculating your jump, your jump is helpful if you have to make the graph yourself instead of reading from the graph. Like if I was asked to make the graph, the jump would be helpful because I'd know how far to move over before I make my major point. So the jump is found by taking your period and dividing it by 4, and it's always 4. Okay, you take your period, divide it by 4, that tells you your jump. In this case, 120 divided by 4 is 30. So what that means is that every 30 degrees I have a major point. Okay, so if I started here, that means 30 degrees later I have a major point. 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 Okay? So it's all these like major points. Now the graph does exist between the major points. It's just that I only need major points in order to graph it. I don't need to know the ones in between. All right, once you have all of this information filled out, you'll take it and use it to make your 2 equations, okay? So to make an equation for a sine and cosine function, here you have just the general layout of what it should look like, okay? Y will stay Y, and your theta is like your x in a function, okay? Because on our x-axis here, it's degrees, so angles are often measured in degrees, so that's why there's a theta here. So this is like your x. So x and y stay x and y, just like in any other function. Things that you need to fill in are the amplitude. Okay, you have to fill in whether it's positive or negative. You have to fill in your frequency. You have to fill in your horizontal stretch and your vertical stretch. Okay, so this is amplitude. Okay, this is your horizontal shift. This is your vertical shift. All right. So your horizontal shift ends up being the opposite of what value you think, and your vertical shift ends up being true. Okay, and I'll talk about that in a minute. You can either make a sine function, so you'd write sine here, or you can make a cos function, so you'd write cos in that place instead, but everything else is kind of the same. All right, so I'm going to write my sine function. So if I'm going to write a sine function, I have to pick a sine wave to base my equation off of. So I'm looking for something that has this shape, okay? Starts at a midline and goes up. I could, if I wanted, pick a negative sine wave, okay? That one starts at the midline and goes down. I just gotta pick a sine wave to use as a point of reference. So for me, I think what I'll do is I'll go from here to here. That's a sine wave. If you have a highlighter, use a highlighter to highlight that section. So this is actually a negative sine wave, okay? Because it starts at the midline and goes down. So when I go to write my equation, I need to put a negative out in front and then the word sine, okay? Now, in between these, you write the amplitude. The amplitude we found out was 2 over here, okay? So I put -2 sine. Then I put my frequency. My frequency was 3. All right. Now, this is your horizontal translation. Horizontal translation is how much left or right the graph shifts compared to the parent version. So in the parent graph, for a negative sine wave, it started at 0, 0. Okay, that was the parent. So if my graph started at 0, 0, I wouldn't put any horizontal translation here. I wouldn't put any number. But this graph is starting at its midline and going down. That start point is at 30 degrees, okay? So it's 30 degrees to the right of what the parent was. So since it's 30 degrees to the right, I put in negative 30. I put the opposite, 30 to the left. Okay? So whatever it shows up here, like 30 to the right to get started, I put the opposite, negative 30. Now your vertical translation is how much up or down your graph is compared to the parent. So here's the parent. It started at a y value of 0 for the midline. This one has a midline at 4. So you use your midline to help you figure out how much vertical shifting there is. So our graph has a midline at 4 compared to the parent, so we'd put plus 4. So this is what I mean by the vertical translation is true, like it went up 4, so I put plus 4, but the horizontal translation is the opposite. It went 30 to the right, but I kind of mark it as 30 to the left, minus 30. Now, that's the sine function. You can also write a cos equation for this too. So I have to go pick a cos wave as a reference point if I'm going to make a cos equation. Now, there's actually infinite sine functions I can make for this. Like, what if I didn't pick this wave? What if I picked this one? Okay, it would have a different horizontal translation. Or what if I used this as my start point and did a positive sine wave? I would have a different horizontal translation. It would say positive sine instead. So there's all possible answers. There's like infinite correct answers. But I usually just try to use the wave that's closest to x equals 0. Those are the ones that I use, and that makes it easier for me to mark, so I don't have like 25 million different correct answers to think about. I just use the ones that are closest to the x equals 0. Okay, when you go to write your cos graph, a lot of these values stay the same. Okay, your amplitude stays the same, that doesn't change. Your frequency doesn't change, and your vertical translation doesn't change. All of those stay the same. The only thing that's going to change is whether it's positive or negative and what the horizontal translation is. Okay, so we got to go find which cos wave we want to use. I'm going to use a positive cos wave that starts here and ends here. Okay, the reason why I want to use this one is because then there's no horizontal shifting to worry about, because a parent cos wave starts at a crest, goes down, and comes back up to a crest. That's what this one's doing. So there's not going to be any horizontal shifting because the parent starts there too. Okay, so here is my cos graph that I want to use for reference. It's this one. Okay, I could have picked this one if I wanted to. I would just have a different horizontal translation. Okay, I'm going to use this one. All right, now there's no horizontal translation because it's starting at x is 0, just like the parent. Okay, so I can put plus or minus 0, or I could just not put anything. I just leave it as theta, that's all. I got to put whether it's positive or negative. This is a positive cos wave. A negative cos wave would look like this. All right, this is a positive cos wave, so I put a positive. So there, the cos wave is done. The cos equation is done. So both of these are correct answers, but there's also many other correct answers that would have worked as well. All right, I'm going to do example 2, and then you guys will go do the practice in your manual. All right, I'm going to start by marking my midline. My max is at 7. My min is at -1. Okay, that's 8 units. Okay, so -1. That's 8 units. So the midline will happen 4 units down from the max. So 4 units down would be here at 3. Okay, so I should mark a line at the midline because it helps me visualize how much vertical shifting I'm doing. My amplitude is this distance from the midline. Okay, so from 3 to 7, that's 4. My amplitude is 4. My period is 360 divided by Oh, sorry, I don't even need to do that. I just got to count how long it is from start to finish. I don't know what my frequency is, so I can't go 360 divided by frequency. So just pick a start point, like maybe here. And this is the end point. So to get from here to here, that's 120 units. Okay, from 30 to 150, that's 120 units. I could have started here and went to here. That's 120 units too. My period is 120, just like last time. Okay, that's just coincidence. It won't always be 120 for your period. My frequency, which is K, is 360 divided by my period, which is 120. Okay, my frequency is 3 again. That makes sense, because if my period is the same, then my frequency is going to be the same. So these just happen to be the same. You won't always have the same period and same frequencies. So getting 3 just means that 3 cycles happens in 360. Okay, we can only see, here's 1 cycle, 2 cycle. We can't see the whole 3rd cycle, but we don't even need to see it in order to tell that the frequency is 3. The jump, if we want to calculate that, is your period divided by 4, okay, which is 30 again. That just means that it's 30 degrees between every major point. So if I'm starting here, 30 degrees later, I'm at my max. 30 degrees later, I'm at my midline. 30 degrees later, I'm at a trough. 30 degrees later, I'm back at the midline, and so on. So all the major points, the midlines and crests and troughs happen every 30 degrees. All right, here we go. So this will be a bit faster. Our amplitude, we said, was 4, so it's different this time. We can put that for both equations. The amplitude stays the same. Frequency was 3. That stays the same for both equations. The vertical translation is your midline. It's at 3, so we put plus 3, and that's the same for both. So the only thing I need to fill in is the horizontal translations and whether this is positive or negative, okay? So I can pick any sine wave that I see, a positive or a negative one, but whatever one I pick is going to affect what horizontal translation I put down, okay? So if I'm talking about a sine wave, I might as well use this one because this one starts right at 0, okay? So here's a positive sine wave. There would be no horizontal translation because that's where the parent sine wave starts, okay? The parent, this is the parent positive sine wave. It starts at 0, goes up, starts at 0, goes up. That starts at 0. This one starts at 0. So there is no horizontal translation, okay? You would just write this as y equals 4 sine 3 theta plus 3. Over here, we're looking for a cos wave to base my equation off of. Okay, I can pick a positive cos wave or a negative cos wave. I'm just going to use a positive cos wave because that's the one that's closest to x equals 0. So here is, you could use a highlighter to highlight this. Here's a positive cos wave. Okay, so I'm going to use a positive cos wave. It's starting at 30, okay, but the parent cos wave, which is right here, that parent cos wave starts at 0. Okay, so it shifted 30 units to the right, so I put minus 30. I do the opposite. If I wanted to pick a negative cos wave, I could have started here at 90 and went to here. I'd put negative cos and I'd put negative 90. All right, so try your best to do the practice in your manual. And if you guys aren't sure how to do it, maybe ask a friend. You guys can work together to try to figure it out. If you want to message me on Teams, I might be able to answer your question if it's a simple question. Otherwise, I'll see you guys on Monday. I will have your log tests marked, and you have a rewrite available if you want to rewrite the log test. It'll be next Thursday. Okay, so you'll get your test back Monday, and then the rewrite is Thursday at lunch, and you have to message me on Teams if you want to do the rewrite. Okay? So I'll talk to you guys later on Monday.